If a metal sphere and cylinder are both released from rest in a race down an incline, which would win the race to the bottom of the incline? So I'm thinking of maybe a scenario kind of like this. Here's an incline. At the bottom, things level out. And here is a cylinder and or a sphere, because when I draw it on this two-dimensional surface, they really are going to look the same. And it rolls down and then winds up down here with some velocity v. So to answer this question, the way I'd like to think about this is to recognize that in the initial state for this system, the kind of energy it has is really gravitational potential energy. So I'm just going to say it has some fixed amount of mgh. And if we want to, we could maybe say that this sphere and this cylinder have the same mass, just to make the comparison fair. But it turns out, if you actually calculated what this v would be for either scenario, the mass would actually cancel out. So it turns out whatever answer we get is going to apply to any set of a pair of a metal sphere and a cylinder, even if they are unequal in size. What winds up mattering, though, is the fact that for a sphere, the moment of inertia is equal to 2/5 m r squared. But for the cylinder, the moment of inertia is equal to 1/2 m r squared. And when either of those two objects is down here in the final state and rolling, the kinds of energies that it has there is ordinary kinetic energy, 1/2 mv squared, but they also have rotational kinetic energy, 1/2 I omega squared. So the difference in these two formulas for the moment of inertia would make the difference in this part, this rotational part of the kinetic energy, once it's finished rolling down the incline. The cylinder, because it has the larger number, right, 1/2 is larger than 2/5, that really reflects the fact that there is more matter distributed at larger distances from the rotation axis for a cylinder as compared to a sphere. That means if you ask, like, well, how much of the overall kinetic energy is rotational down here, the cylinder would have a larger amount, a larger percentage, a larger proportion of it be rotational because of that larger amount of, rotational inertia. So that means that given the amount of energy that was available to begin with, the sphere is going to have more available for linear kinetic energy. That's one way of thinking about it. Maybe the math might turn out a little bit different because, like, for example, if I said, like, what is the total kinetic energy for one, let's say for the sphere, the way that might look like, and this really is going to be the final energy that I'm describing here, because all of it's kinetic at that point, linear plus rotational. The rotational part, though, using 1/2 I omega squared, and I said I would do this for the sphere, I think, right? So we'll put in 2/5 m r squared times omega squared. But the thing is that this r squared with the omega squared, that really is just going to be a v squared, right? Because r times omega is v. So here I would get, if I kind of maybe cancel some 2's here, I'd get like 1/5, I meant to put 1/5 m v squared. Well, what would have happened, right? Because this, like I said, this was for the sphere I did here, right? What would have happened for the cylinder in terms of the final energy is its final energy, really its total kinetic energy, linear plus rotational, would be 1/2 mv squared. Well, if I look at the way this turned out, instead of this 2/5, I'd have a half there. Half times a half would be 1/4 mv squared. So at the end of the day, let's see, 1/5 plus 1/2, I think, is 7/10, right? mv squared. And this one would wind up having 3/4 mv squared. And so for the cylinder, this number is larger, which means V would have to be smaller. So long story short, because more energy gets tied up in rotation, the sphere will be going faster. So when we say, well, which one would win the race, that would already start to, like, the final speed it gets to would also reflect how the two are speeding up as they go down. So in other words, the conclusion that the sphere is going faster also means that the sphere is going to win. So that's what I'm saying. Maybe I should put a circle here around the sphere to clearly indicate that that's the answer I'm presenting. The sphere is a winner, and there is the result. And this is something you could maybe, if you have like a cylindrical object and a spherical object, and then, you know, maybe some, like either a book or something else, maybe a tray. Maybe you could even use a tablet, although don't hurt your tablet, right? But set the two up with, like, you could use a ruler or something else, or maybe even a pen, and set the two of them up and to lift the pen so that they both simultaneously start. You can see, you know, actually try this out and see that the sphere would beat the cylinder.